அவன் கிளம்பிட போறாரு. ஜிபிஎஸ்டி மட்டும் என்ன தெரியல, அது சால்வ் பண்ற மாதிரி இருந்துச்சு. அது கொஞ்சம்
Good evening, one and all to present here. I am happy to welcome the last day of the last session. So I think last 5 days we learned something from MATLAB. So what we started in the last session, we started with the help of how we are going to generate the plots. From the plots, how we are going to generate pie plot. Then other plots also we discussed. With the help of plots, how we are going to assigning x-axis label, y-axis label, then how we can add for the legend. With the help of the legend, we can choose the position wherever we need. Then if we have the data from the x-axis and y-axis, we can add it for the specifier. So specifier also we can add either it is solid, dotted, dashed, dash, dot, etc. Then we are going to choosing with the help of the specifier colors like red, then green, blue, then CMYK, cyan, magenta, yellow, black, etc. Some specifiers we can add with the help of symbols like plus symbol, circle symbol, asterisk symbol, then points, squares, diamond, etc. Then we create the plot with the help of function plot also we generated. Then we tried whatever we have the equations. If we have the polynomial equation like x squared plus 3x plus 4 is equal to 0 means how we can generate the plot depends upon the value of x. Then we can try to add from the multiple graphs in a same plot. So that is also we added. Then we add the title of the plot, axis of the label, change the range of the axis, legend, text blocks, grid box, etc. So that is also we discussed in the last session. Then today we are going to start with the help of some graphics also we discussed in the last session, how we can generate a bar chart, then how we can generate it for the contour diagrams, then how we are going to generate it for three-dimensional plot. So we know about it. What is the procedure for generating the three-dimensional plot? So how we are going to generate it for this three-dimensional plot means we know the procedure. We can add the value with the help of mesh grid. From this mesh grid, we can add the self command. This self command, we are going to create the self plot also. So that is we discussed in the last session. So what today we are going to discuss, then what are the major topics is available from in this session means we show about it. So how we can add it for the algebra formula from in MATLAB. So how we can add it, the algebra formula from MATLAB with the help of some simple code. So first we know about it. Okay, how we are going to solve any type of algebraic equations. We can add or we can easily solve with the help of the solve function. It is used for solving any type of algebraic equations. So we have the algebraic equation. The simplest form we are going to solve the function. It takes the equation enclosed in the quotation as an argument. Sometimes we have the equation like x in the equation is x minus 5 is equal to 0. Then what is the value is x? X we can write it x is equal to 5. So if we have this equation, how we are going to solve it with the help of in MATLAB means we can write the equation y is equal to solve, then x minus 5 is equal to 0. This is, we can write it in the quotation symbol. So this is the easy procedure how we can solve it any type of algebraic formulas. Then another one is how we can solve it this type of equations like b minus u minus 3 star t power 2 is equal to this 0. Then roots also we can find it 1 minus 5. Then how we are going to solve it this type of equation with the help of in MATLAB means that is easy way we are going to solve this type of functions. So first we are going to solve it. Y is equal to x, then dash or x is minus 5 is equal to 0. Then what is the value we are going to getting? The x value means x is equal to 5. Then another value also it shows v minus u like. This type of equations means how we are going to solve it, some MATLAB functions. First we are going to solve it. Yeah, if we have any type of quadratic equation, then we have the quadratic equation, we are going to solve it with the help of in MATLAB. How we are going to solve easily from this MATLAB? Yes, Divya, please stop your video. Yeah, if we are going to solve it, any type of mathematical equations, that is, we are going to solve it for the quadratic equation. How we are going to solve it? The quadratic equation, for example, we have the equation is, that is x power 2 minus 7, 7x, then multiply with x plus 12. After writing this equation, we are going to solve it. The equation is solve equation. If we can write it for this solve equation, okay, then we can add it for is display the first root. What is the root value of s of 1? Then what is the value of display s of 2? That is the second root we want to display. How we can solve it? This type of equation means we can add the quadratic equation with the help of the function is solve function. We are going to solve it any type of equations with the help of in MATLAB. So we can solve it this. So with the help of in solve function, we are going to solve any type of equation which we have in the value of the higher order equations like. So we are going to solve it, this type of higher order equations with the help of in active. So this fourth order equation, we are going to solve it with the help of this MATLAB. So how we can solve it means we have the equation is x power 4, 7x power 3, then plus 3x power 2 minus 5x plus 9. If we have this equation means how we are going to solve it with the help of in MATLAB, then what is the value of root we can call. Yeah, we add or we are going to solve any type of higher order equations. Like we have the equation is x power 4, 7x power 3, 3x power 2 minus 5x plus 9 is equal to 0. That means we can write it. The vector values are this x power 4 means only 1x. So 1. Then x power 3 is minus 7. 3x power 2 means 3 minus 5 plus 10. Then we can find the root value of this b. So we can write s of roots b. Then display what is the value of the doubles s of 1, doubles s of 2, doubles s of 3, double s of 4. If we are going to solve it, the same equation with help of in MATLAB means we can write it vector, then root value, then display, that is the numeric value of first root. The first root is 6.63. we solve it, this type of higher order equations. Here it shows the double of S1 means the numeric value of the first root of this equation is 6.6. Then the second root value for this, the numeric value is 1.05. Then the numeric value of the third root is minus 0.34. Then the fourth root is minus 0.3451. So this is the way we are going to solve it, any type of higher order equation using MATLAB. So how we can solve it means, this is the easy way we are going to solve it from the MATLAB. Then another one example we are going to solve it. We have the two equations. What equations we have? The first equation is 5x plus 9y is equal to 5. The second equation is 3x minus 6y is equal to 4. If we have this type of equation means, how we are going to solve it? So the simple procedure we are going to solve it. Just we can type solve, then we can write it. This 5 power x, then 9 power y, then 5, then 3 star x minus 6 star y is equal to 4. Solve it, the system equations in using MATLAB means, we have the equation like this, the first equation, then second equation. How we can solve it? Then s dot of x, then s dot of y. If you write it, what is the value of x, what is the value of y, it will calculate it with the help of in MATLAB. Then we can do the various calculuses with the help of in MATLAB. How it will solve it, this type of problems means, from with MATLAB, it will provide for the various type of solving problems of differential and integral calculus, the solving differential equations of any degree and calculations of limit. How we can calculate it for the limit means, the best of all, you can easily plot the graph of complex function and check which is maxima and minima. And other stationary points also we are going to solve it. The original function, it can be derived. how we are going to calculate it for the limit value means the MATLAB is also provided for the limit function in calculating the limits, which is the most of the basic form from the limit function. We can take the expression as one of the argument. That arguments we are going to find the limit of the expression as the independent variable is goes to the value is 0. For example, we are going to calculate it, the limit of the function like f of x is equal to x3 plus 3 plus 5 divided by x4 plus 7 as the tends to 0, we can find the limit value. How we can show about it? The limit value means it's we can find it limit of x power 3 then x power 4 plus 5 plus 7 divided by this. So we can add, this is the way we are going to add it for, or we are going to show about it, the limit value with the help of MATLAB. Then how we can do the various limits, either it is the left and either it is the right side. How we can solve it? This left side and the right side limit means we can add with the help of the function is we can utilize EZ plot. So here we can know about it, f of x is equal to x minus 3 divided by x minus 3. So that value we are going to solve it. How we are going to solve it means we can add for the value of the limit like limit of x then 3 f of x is does not exist means MATLAB is also helps to establish this type of fact in the two ways. First one is using the plotting the graph of the function and is also showing the discontinuity. Then by computing the limit showing the both are different. How we can add it for this left-handed and right-handed limits? This is also we are going to compute it by passing the character string left and right. The limit command is also last argument we are going to add. For example, here we have the example is f is equal to x minus 3. Then absolute value of x minus 3. Then epsilon we can write it z plot f minus 1 comma 5. Then we can find the limit of left then limit of right. How it shows for the limit of left and limit of right means the equation it shows from here x minus 3 absolute of x minus 3 then the value of left limit means it shows the line is left limit of the value then right limit of the value it shows from here. So this is the way how we are going to show about it after finding the limit value from the showing is discontinuity of the plotting the graph. Then the both limits is are different. Then another one concept is that is the differential equations. We know from this mathematics the differential equation is the major we are going to solve it any type of problems. So that time from the mathematics from the differential equation in MATLAB it provided for DIF, that is the command. This command we are going to solve it any type of differential equations. The command for computing symbolic derivatives is simplest form you are going to pass the function what you want to differentiate to different command is an argument. Here we have the equation that is f of t. So f of t is equal to 3t squared. Then we know about it plus 2 multiply with t power minus 2. Then we have the value is finding the differential value of this equation. How we can find the differential value for this equation means the simple procedure. What is the equation we have? We can assign with this f. Then we are going to calculate this diff of f. That means it shows what is the value of the differential from 3t squared plus 2t power minus 2. Then another one, how we can find the minimum and maxima which we have the curve. With the help of in minima and maxima, how we can calculate it means that is the easy procedure we are going to solve it. So previously we said about it. Okay, that is we have the function we can add for Ez plot. So same here we can add for showing any type of minima and maxima of the curve. So if we are going to searching local minima and maxima from the graph, we are basically looking for the highest or lowest points on the graph of the function. And particularly is locality of the particular range of values of symbolic variable. For example, the function is y is equal to f of x. The points on the graph where the graph has zero slope are called stationary points. So here from the function is f of is equal to 2x power 3 plus 3x power 2 plus 12x plus 17. Then we have the value of f dash of x is equal to 0. How we are going to generate it for this type of value with stationary points? We can generate it for the plot means we write it y is equal to 2 power that is 2x power 3 then 3x power 2 minus 12x plus 17. Here we are going to defining the function of y. Again we are going to call it that is the function we have the function we are going to utilize that is Ez plot. So with the help of Ez plot, we are going to call it Ez plot of y. Then the plot is generated. This is the format it will generated for the plot with the help of Ez plot of y. So this is also one of the procedure we can calculate it for maxima and minima of the curve. Then the next one is that is polynomials. From this MATLAB polynomials, how we can solve it this type of polynomial equations. So here the MATLAB is represents polynomials as row vector containing coefficients ordered by descending powers. For example, the equation is P of x is equal to x power 4, 7x power 3 minus 5x plus 9. If we have this equation means how we can find the value is P is equal to 1, 7, 0, then minus 5, then 9. If we can write it for that is the value we can assign with P, then we can call the polynomial value of this equation means what is the result it shows with the help of in MATLAB. So we are going to try with the help of MATLAB. So what is the polynomial value of the given equation? So we tried any type of equation we have tried for the polynomial values. So here first we can try to do for the first equation. The first equation is P is equal to the value which value we can add from the MATLAB. The first value is P is equal to 170 minus 59. If that is the first value means we can find it the polynomial value. So the polynomial value it shows 693. So this is the polynomial value of the given equation is 170. So how the equation is shows means x power 4 plus x power 3 minus 5x plus 9 is equal to 0 means the polynomial value it shows 693. Then another one is we are going to finding the polynomial value of the another equation. The another equation is also x power 4, 7x power 3, then minus 5x plus 9. If we have this equation, we have the x values are 1, 2, minus 3, 4. Then 2, minus 5, 6, 3. Then 3, 1, 0, 2, 5, minus 7, 3, 8. If we can find the polynomial value of p comma x. So what is the value of the polynomial value for this equation? That is the root, we have 1, root 2, root 3, root 4. 4 roots of x value we can find, which have the equation with the help of in the polynomial. So this type of equation we can solve it easily with the help of MATLAB. Then another one concept we know about it. Here we can solve it. The other equations, what equations we have from in MATLAB means we have this type of equation. We are going to solve it in MATLAB. How we can solve it? This type of polynomial equation. Then how we can generate it for the plot from with the help of in MATLAB means that is the easy way we can add. So what we are going to add with the help of this MATLAB means we can try to add some simple function. What function we can add means here x is equal to this, then 1, 2, 3, 4, 5, 6, y is equal to 5.5, 43.1, 128, 290.7, 498, 978.67. From this data, we are going to generate it for the polynomial value. The value is x comma y comma 4. Then we are going to generate the pie plot for the value of x2 and y2. What we have the x value and y value. Then we are going to generate the pie plot what value we have. So how we can generate it for this type of plot? Whatever we have the polynomial values means we can try to generate a pie plot with the help of MATLAB. Just we can start the same code, we can try to find it. It shows for the diagram of the plot is, we can find the p value is this 4.1056 is the root of 5, root of 4, root of 3, 2, 1. Then we have the value of x, y. It will generate for the pie plot. The pie plot value it shows 0, 2, 3, 4, 5, and 6. This is the plot we are going to generate with the help of MATLAB. So that is the figure it shows. It will generate this type of plots. So which equations we have? From this equation we are going to solve it. That is a procedure we are going to solve it, like the plot also in polynomial. The next one is with the help of in MATLAB, how we are going to find the calculus limit. So that is also we can solve it, the limit value with the help of f of x, x3 plus 5, x4 plus 7 as what is the value we have. That is also we saw about it in the previous slide itself. Then next one is from in MATLAB, that is the concept is there, GNU active. What we'll do from this GNU active means, here it's one of the high level programming language. It is mostly compatible with MATLAB. It is also used for numerical computations. Then Activa has the various features within MATLAB. What are the various features it supported for this MATLAB means? One is matrices are fundamental data type. Then it has built-in support for complex numbers. It is also built-in math functions and libraries. It is also supports user-defined functions. So how the various features with MATLAB, if we have in GNU active. This GNU active is also freely redistributable software. You may redistribute in modify it under the terms of GNU General Public License as published by Free Software Foundation. So you can also utilize this GNU active. With the help of in GNU active, what we will do it, what it help, how we can do it. We are going to compare with MATLAB and active. Most MATLAB programs run in active, but some of the active programs may not run in MATLAB because active is allows only which syntax that have MATLAB is does not. For example, if MATLAB is supported for the single quotation, supports both single and double quotation. When we are going to determine or when we are going to define any type of strings. So there is a simple difference we have in MATLAB and active. So here we can try to do some simple example with the help of in MATLAB and active. So what it shows the difference with the help of in MATLAB and active. So what is the code we have? The first code we are going to generate it for with the help of in 3D. So 3D means we know about it, how it will generated with the help of in mesh grid and self function also we can utilize. With the help of self function, we have 3 axes we want to add. So with the help of this code, what output we are going to get in MATLAB, then how we can generate it for then 3-dimensional diagram from MATLAB. So we will create it for some simple diagram with the help of in MATLAB means we can try to do the same code what the 3D diagram it stores. So just we can try to the same code in MATLAB. What it shows means how it will generate it for the diagram with the help of this MATLAB. So here we can add for this code how it will generate it for the diagram. So the 3-dimensional diagram is generated like this. So what is the value we have? Then how it will generate it for the figure with the help of in 3-dimensional. So here we have the values are start with -2, that is -2. Then we can using .2 is the increment value. Then maximum is +2. Then g is equal to x multiplied with exponent of -x power 2 minus y power 2. Then self we can using this function. The values are x comma y comma g. So that is the function we can utilize. Then the diagram is generated. This type of diagrams we can generate with the help of MATLAB. Then another one option we can add from this Activa. Here we can write f is equal to x power 2 cos x, then ez plot minus 4 9 the function, then int the function of minus 4 and 9. Then here we are going to create it for this type of diagram in display in the double area format. Yeah, the next one is, okay, from the MATLAB, that is also a very interesting topic, how we can utilize for this Simulink, that is Simulink. So Simulink is one of the different model. This model we are going to add with the help of in MATLAB. How we are going to add this type of model means, we know for the simple syntax, we know with the help of that symbol we can utilize. How we can utilize for this type of symbol means, that is the easy procedure we are going to call. How we can call it this type of simulation with the help of in MATLAB means, so I'll show about it, the procedure you can try to do for with the help of in simulation. So simulation is also supported for the various concepts. What concepts is supported means, it's supported for like the system level design, simulation, automatic code generation, testing, verification of embedded system, etc. So Simulink is the simulation model based design environment for dynamic and embedded systems. So this is also integrated with MATLAB. From the Simulink, it is also developed by MathWorks. With the help of the MathWorks, which data we are going to create for the flow of graphical programming language tool for modeling, simulating, and analyzing multi-domain dynamic systems. It is basically is a graphical block diagramming tool with its customizable set of block libraries available from in MATLAB. I show about it, the simple procedure of how we are going to import this Simulink. After importing, how we are going to utilize, what other possibilities is there. From MATLAB, if we have the calculus equation, we are going to add for the various product with the help of in MathWorks. And this is a third party hardware and software product that are available for using Simulink. The following list we have from in Simulink. What we have from the Simulink means, we can generate it for any type of flow chart or state machine diagram means, we can add it. The function is state flow. This is allowed this type of machines and flow charts. Then Simulink coder is also allowing generation of C source code for real-time implementation of systems automatically. Then we have XPC target together x86 based real-time systems. It is also provided for the environment to simulate and test Simulink and state flow models in the real time on physical systems. Sometimes the embedded coder is also supports some specific embedded targets. Then HDL coder is also allows to automatically generate the synthesizable VHDL and Verilog. I'll show about it some suitable example for the Simulink. Then we easily understand how we are going to import, then how we are going to utilize the Simulink from in MATLAB. The first step we want to do, we are going to write from this Simulink. With the help of in Simulink, what are the options are there, what are the libraries are there, then how we are going to using this type of Simulink libraries. Here it shows for the Simulink. After writing this Simulink, It's supported for the commonly used blocks, then continuous, discontinuity, or discrete probability, or logic and bit operations, lookup tables, mathematical operations, then model verification and model-wide utilities, some signal attributes or signal routing, sources, user-defined function, etc. So we have from MATLAB, this type of libraries are there, but in particularly, if we are going to using in Simulink means, this is the major libraries are there. With the help of these libraries, we are going to utilize like commonly used block means, from this commonly used block, we have some other sub libraries are there. From this commonly used block, how we are going to utilize this commonly used block or continuous or discrete probability, like means we can start this commonly used block. After starting this commonly used block, we are going to building the model with the help of in Simulink. How we can create this simple new model of the simple new Simulink means, we can create the new model and there is a button is available for new button. We can just start for this new button. From the library browser, we can choose the toolbar. It's automatically open. The title is Untitled Model Window. When after importing the Simulink, we are going to choosing any one buildings. So this type of models we are going to choose. Now we can click this new button. The library browser from the toolbar, it will store that is untitled. From this Simulink, we are going to generate the default model. So that model is created with the help of in Untitled. So from this Untitled model, after selecting this, we are going to choosing, like there is a simple procedure, drag and drop items. Whatever we need, just we are going to dragging and drop it. So here we have the Simulinks, like if we are going to choosing sinks and sources means, we can drag from here what are the option is available from this sinks, then what are the sources available from this, here we can try to drag it. Wherever we need from the MATLAB, just we can drag and drop it. So these type of items are available from with the help of in Simulink. With the single Simulink, we have this type of libraries are there. Whenever we can do for any type of the discrete probabilities, like we can find it the distribution, or we can find it for any other probability values means, we can choose this type of Simulink. Then after dragging and drop, we have any type of the sources we can add in your project. What project you have, from the project you can utilize. So this type of wave, sine wave also we can add. Go to from the source, then we can click from this source, we can add it for the sine wave. We want to import the sine wave format in your project. Like the digital clock also we can add it. Sometimes we can add it for the random numbers. Sometimes we are going to add it for the repeating sequence interpretation. Signal builder, uniform random number also, we can use it with the help of these sources. So whatever we have, the other than Simulink, we have the embedded coder, neural network toolbox, then real-time Windows target, then HDL verifier, fuzzy logic toolbox, embedded coder, computer vision, then communication system toolbox is also available. So whatever we need, so we are going to utilize with the help of this Simulink. Then another one it shows if you are going to selecting this sync from the library which is available from in Simulink, then drag the scope of the block into the model. So that means from the library of in Simulink, we can choose the option is sinks. From this sinks, we are going to choosing this type of libraries, like we are going to display, then out, stop simulation, to file, XY graph, then floating scope, various scope, then terminator, to workspace. So these type of libraries we have with the help of sinks. Whatever we need for our project, you can try to add. Sometimes we want to add for the timer. So that is also you can add in your project with the help of these Simulink libraries. Then the next option, whatever we need for the signal line. So we selected the wave format. After choosing the wave format, we are going to add for the sine wave. So we can drag the signal line from the output of the sine wave block to the input of the scope block. So this type of signal, sine wave and scope also we can add in our project. So whatever we can do, we can add it for with the help of in Simulink. Then we are going to using this Simulink, we can give the drag in signal line from the output. We can create it for the input from the scope of block. We are going to give the input from the sine wave. Then we can give the connection with the scope. We can add the another option from the scope. So this type of charts we can generate it with the help of in Simulink. So this is the simple and sample. We are going to add any type of other models in your MATLAB projects. So that is you can try to do. Then the simple procedure you can follow, how we can import it for this type of Simulink options. Then another one major concept from in MATLAB. So we said about it, there is available for the lot of toolboxes. So what type of toolboxes is supported for the various research work? So here I'll show about it, some simple toolbox, how we are going to utilize from in image processing research. So here it will show in the image processing using MATLAB. With the help of an image processing technique, we are going to convert whatever we have any type of image into the digital format. After converting this digital format, we are going to perform the operations or into get an enhanced image or extract some useful information from the images. Whenever we are going to change the take place of image are usually performed automatically and rely on carefully designed algorithms. So image processing is also multidisciplinary field with the contribution from the different branches of science, including mathematics, physics, optical and electrical engineering. Moreover, in overlap with the other areas such as pattern recognition, machine learning, artificial intelligence, and human vision research. These are the major areas it supported for image processing concepts using MATLAB. Sometimes the different steps is involved in MATLAB means using image processing. It is also importing the image with optical scanner from the digital camera. After analyzing and manipulating the image like data comparison or image enhancement and filtering. Sometimes we are going to generating the desired output image. So this is the very interesting when we are going to do for image processing concepts from MATLAB. I'll show about it, some simple image processing concepts, how they are doing for after importing the image, how they are analyzed, like how they are increasing the enhancement, decreasing the enhancement, how they are apply the various type of filtering technique, then how the data is compressed with the help of image processing algorithms. Here, we need to extract the information from the image and interpret their content has been driving factor in the development of image processing. So this is also finds its use numerous sectors including medicine, industry, military, consumer electronics. So this is the various numerous sectors it's also including with image processing. Then another one major industry from image processing is that is health industry. Then medicine, it is the used for diagnostic imaging modalities such as digital radiography, then PET images, positron emission tomography, computerized axial tomography, that is CAT, then MRI, magnetic resonance imaging, and functional magnetic resonance imaging. So fMRI. So it's highly supported for the MATLAB from the medical industry. So from the medical industry, there is captured lot and lot images. How that type of images are we are going to process with the help of in MATLAB means we are going to utilize this image processing MATLAB from we can import it for MATLAB toolbox from image processing. Another one is that is the industrial application. It is also including manufacturing systems such as safety system, quality control, automated guided vehicle control, etc. So this type of systems is supported from in the area of manufacturing. Okay, then I show about it some image processing algorithms with the help of the algorithm, how they are solved it or how they are diagnostic with the help of medical images. Some complex image processing algorithms also used in applications ranging from detection of solids and vehicles to missile guidance and object recognition and reconnaissance. From the biometric techniques, it's including fingerprinting, face masking, IRIs, and hand recognition are being used extensively in law enforcement and security. Sometimes, after capturing the image with the help of digital cameras or camcorders, we need to increase the resolution. So that's why we are going to utilize this image processing concepts like high definition, televisions, monitors, DVD players, personal video recorders, and cell phones are popular consumer electronics items using image processing. I'll show about it with the help of in image, what image we have, with the help of the image, how we are going to do for some simple enhancement with the help of MATLAB. Then we know about it with the help of MATLAB, we are going to do for some simple enhancement technique or simple procedure we are going to follow it. How we are going to follow it, this type of images, then this type of procedures, how we can do it means here we are going to read the image with the help of in MATLAB. The procedure is we are going to using the function is I am read. Then we want to give what is the URL for that image with the extension is JPEG. Then after reading that image, we can show about it. This various class we can add that with the help of in subplot. The first image we can show, then the second subplot we can show about it. That is RGBs to gray image. Then third plot we can show about it. That is IM to the black and white image. Then the fourth plot we can show about it. This adjustment of blank. Then RGB2 is the gray color for the fifth image. Then we show about it the information about the image from here. I am info. Then the height, width, contour plans, and size. How we can utilize the image processing concepts with the help of MATLAB. From with the help of in editor window, we can add this type of code means it will generate it for one figure image. Then first it will source from this plot 1, plot 2, plot 3. From this plot 1 is source for the RGB to gray color. That is the original image is sourced from the plot 1. Then RGB to gray. Then IM to black and white. Then there is the adjustment image is source. Then gray color image is source. That is 2, 3, 5. So this is the procedure we are going to follow. Then we want to import that image processing with graphical user interface. How we are going to import it for this GUI from in image processing. So we are going to follow it for creating the MATLAB graphical user interface for image processing. First, we are going to building the graphical user interface for image processing. Launch the GUI by typing the command. What command we are going to type means just we can write it the command window, that is guide. So if you type from this guide, so what it shows? It shows the various blank. It shows with the help of the blank we are going to generate the options whatever we show about it. So just we can start from this MATLAB. From this MATLAB, just we can type that is guide. So what it shows, the window it shows, there is a quick guide it shows. Creating new GUI or open existing GUI, the blank, then GUI with UI controls, GUI with axis and menus, then model question dialog, etc. So this is the way how we are going to generate it or create it for new GUI from in MATLAB. So after generating this guide, after choosing this blank GUI, then we can click to the button is OK. It will go to the resize of the resize. change the shape of the push button axis. Just click and you will be able to drag and corners. So whatever we need, we are going to design it. So here we can add it for the label box, then upload the image, RGB to gray color image, convert that to binary image, then reset. These are the buttons we are going to add after creating for this guide. So we can generate it from the default. From the default, it shows this type of options. I show about it from the MATLAB. Okay, how it shows for the symbols, then how we can generate it. So from here, we can type guide. The box is created for the quick sort. Then after choosing this quick sort, we can click to blank GUI default. Then click to OK means it shows that is untitled figure. From this untitled figure, whatever we need, if we need for this push button, we can add push button. Then if we need for this slider, we can add for this slider. Then if we need to add for the radio button, we can add for the radio buttons. Whatever we need to change it, we are going to change with the help of the properties. Then if we want to add for the pop-up menu, we can show about it, the pop-up menu. Then sometimes we can add this type of graphs we want to generate. That is also we can add for the axis. So there is a button group. Then we can add for the text box. Then we can add for this list box. So whatever we need, we are going to design it. So that is we have done with the help of from which we selected from the buttons like. So here we can design it, this type of buttons. Then this is also buttons, histogram, complement image, edge reduction, rotate clockwise, rotate anti-clockwise. So we can add the axis from here. When we are going to double clicking of any of the buttons, you will be able to change the color, change the string, change the tag. And other option also, that particular buttons it shows, if you want to change it, you can try to change. So it will shows the color, text, title, everything it shows with the help of the properties. Then after customization, it will look which we needed. User can also customizable. So whatever you need, we are going to customize. So we can customize button color, then string, etc. For example, from in MATLAB, we can start from this MATLAB, how we can customize this type of options means from we can select this button, double click or right click or double click. If you go to this double click means it shows the option like this. So that is the inspector it shows, that is the properties like whatever we need to change, we can change it. So here we want to change the text means we can change from the string here. So what text we needed? So for example, image processing. So just we can type this image processing, automatically the button it will change to for this image processing. So if you need for the color, then whatever we need, we can try to change for the font size. Then we can change for the style, toolkit, maximum, minimum. So everything we can change with the help of the user, whatever we need. So that is we have done. After generating this GUI, we can choosing the change of the shape, size, etc. Whatever you are going to customize, the customize button as your choice you can select. Now when we are going to save this file, the code is generated in the editor window of MATLAB. So what we can change from here, we can change for the background color, we can change it, what is the font name and font size, then what is the string which we are going to upload the image, style, tag. Whatever we are going to select here is automatically from the MATLAB, code it will change or the code it will generate. With the help of edit the generator, then the code to set task for different push buttons, whatever we have the code, it will generate. Then after generating the code, how the GUI for image processing code we can generate. If we want to upload any type of image with the help of the function of push button, we can give that type of uploading the button, like upload image we can give, then copy and paste, and whichever we code we have means we can insert from with the help of the command is UIG then ETFILE. That means UI get file, what is the image extension type we are going to choose. It is also used for importing image in the MATLAB graphical user interface. Here we can write A is equal to UI get file. That file name and extension also we want to give. Then we are going to read the image with the help of I am read. So here we can read, that is I am read, which is the image we are going to read. Then axis also we are going to give. Then I am show, which is the image. Then set, what is the data for that image. So this is the commands we are going to displaying the image, uploading the image, set for the axis value, then set for the app data. It will be accessible one of the part of graphical user interface. The other part we can show about it in GUI. For example, we are going to use the common functions which is available from in image processing means after inserting or after whatever we have added, then we can add for this uploading the image, then RGB to gray, that is we can use for RGB to gray, convert to the binary image, reset the image is original, histogram image also we can generate, complement image, then edge deduction, rotate clockwise image, then rotate anti-clockwise image. So that we have done with the help of the image processing functions. We can rotate it, we can rotate an anti-clockwise, we can finding the edge deduction, we can set for the complement image, check it, we can generate histogram image, then reset image as the original, convert to binary, convert to grayscale, then importing the image. These are the common functions are used from in image processing. Then the next one is how after generating the project, how it shows, how the code we can generate for this GUI. Yeah, so whatever we are going to design from MATLAB, it shows buttons are like uploading the image. Whenever we can click for this, we are going to upload the image from this location. Then RGB to gray means the same image we are going to change the image RGB to gray. Then we are going to convert binary image means it will change the binary image. Then reset means the image, it will reset the image. Then we are going to select this button for histogram, it will change to the histogram image. Then complement image means it shows for the complement image. Then we have the x direction, it will start for this x direction image, it will source for the x direction from this location. Then rotate clockwise, then anti-clockwise also we are going to rotate. That is we do with the help of this MATLAB function. So we are going to use it, these type of options from image processing using MATLAB. For example, what is the code we are going to add it for? The simple code from each button. The first button we are going to convert it for, okay, which we have in RGB to gray. So how we can write it for this RGB to gray means we can copy and paste which is available from here. So here we can add it for RGB to gray. What is the image we have? That image we can change to RGB to gray. Then convert to binary means we can add the code for converter to binary, that is IM to black and white. So that is the code we can add the entirely. It will change to entire image in the format of black and white. Then another one example from we can add it for the reset image means it will reset all the image which is we have in the original image. Again, we have changed for the same image in the histogram format. So we can write it I am hist. That is we tried from the previous example also. So that means the entire image it will change to in the histogram format. Then another one is we are going to convert it for the button, which button we can convert it in the complement image. So the complement image means it will, with the help of the complement function, it's inserted the graphics file. Again, edge detection means here we have the lot of edge detection techniques is available from in image processing. So here we are going to add for simple edge detection, that is called canny method. We can add for the edge detection. The entire edge is extracted with the help of this edge detection techniques. So what it shows for this edge detection image means it shows which we have from the image. Then the next one is we have for the conversion to the edge detection. So for example, okay, the clock rotate, we want to rotate it in the clockwise. How we are going to rotate it for the clockwise means we can write it, that is I am rotate. So a clock means anti-clockwise is rotated. Then we can write it for I am rotate in the anti-clockwise in 90 degree. This is 270 degree. This is 90 degree. We are going to rotate. Then we are going to do with the help of in MATLAB after writing this code from the editor window. We can try to run this code. The location is available for this run. If we are going to run this, so what it shows for the result means it shows for the result like this. First uploading the image, gray, RGB to gray, then convert to binary, reset, histogram, etc. So we are going to import some simple image. That image is the original image is this. We are going to convert it for the grayscale image. Then grayscale image we can convert it to for binary format. Then binary format we are going to convert it to the complement image. Then we are going to convert it for edge detection using canny method. So it will change to like edge detection like this. Again we are going to convert it to for histogram image. What we have the histogram image, which is we uploaded the image. So this is we have the procedure for how we are going to, after uploading the image, we can do for this type of simple image processing concepts, whatever we have the image. Yeah, now do you have any doubt or any clarification? Please write from chat box. Okay, I am expecting 3 to 5 participants try to give for the feedback. So today is the last session. So just you can give for the feedback what you learned last 6 days. You can try to give feedback. You can give feedback via chat box, or you can give feedback. Please unmute your mic, then you can give for the feedback what you learned last 6 days.
Can you hear me, sir? Can you hear me?
Sir, yes, sir, yes, sir. Hear me, sir.
Can you hear me, sir?
Yeah, please introduce, then you can give me the feedback.
Actually, I am Radhakrishnan, Dr. Radhakrishnan, Vaishnav College, Chennai. Actually, I attended your program for the past 6 days. You started with the basic methods. From elementary onwards, you started. Actually, it's more or less related to mathematics. I enjoyed a lot. I learned a lot. But whatever I learned, I have to practice. You explained in a simple manner. So thanks to you and your organizers. Thank you very much, sir.
Yeah, thank you, sir.
Hello.
Yeah, yes, please. Anybody wants to give the feedback, please unmute your mic, then please give me your feedback.
Good evening, sir. Good evening, sir.
Yeah, good evening, sir.
Sir, this is Gautam R, research scholar from SRM Institute of Science and Technology, sir. I attended all your sessions. It was really helpful, sir, because you taught us from the scratch and you took us to the various process. Thank you so much, sir. It was very useful.
Thank you, sir. Thank you for your feedback.
Sir, from obvious. I'm assistant professor. It's really very helpful for me, sir. Whole package of I was using the
Yeah, thank you, sir. Any other?
Good afternoon, sir. This is Anita from Electrical Engineering College, Namakkal. So, our session is very useful for us, but in the practical session, we are very weak to understand. So, we will try to implement soon for the practical session. Thank you, sir.
Thank you, ma'am. Thank you. Any other? Please give me your feedback.
Hello, good evening, sir. Hello, good evening, sir.
Good evening, sir.
Very useful sessions.
Yeah, please proceed. Yeah, anybody, please give me your feedback. What you have studied last 6 days.
Hello, sir. Good evening, sir.
Good evening, ma'am.
Ma'am, sir, I'm Madhumita from MOB Vaishnav College. Really, sir, this session online trading program, it was really useful, sir. I explored more things and learned new things. Really, it was useful. I was just wondering whether we can do even these using MATLAB. I thought it would be more complicated, but it was based on the basics of C. So it was very useful and easy to understand. Thank you, sir.
Thank you very much, ma'am. Any other?
Hello, good evening, sir. I'm Dr. Felsi from Bangalore. I attended all your 6 days session. It was really good. It made us to work. The time was not enough. So next 6 days, it made me to work. I think I have to work. It was very informative, sir. Thank you so much.
Thank you, ma'am. Thank you.
Wales Institute of Science, Technology and Advanced Studies, Chennai. I attended your previous all training sessions also, and MATLAB also I attended all the 6 days, sir. So the way you explained, and the main thing is you also at the same time you parallelly worked on that, and you showed us how actually it will work on that MATLAB also tool also. So it was very useful, sir. Thank you.
Thank you very much, ma'am. Any other? Please give the feedback for last 6 days. What you learned from the online training on MATLAB.
Good evening, sir.
Good evening.
I'm Sriram from Mutayama College of Science, Rajpuram, sir. Sir, MATLAB நிறைய விஷயத்தை நாங்க கத்துக்கிட்டோம் சார். எக்ஸெட்ரா இன்னும் MATLAB இப்ப எப்படி யூஸ் பண்றதால நிறைய கத்துக்கிட்டோம் சார். தேங்க்ஸ் ஃபார் யுவர் செக்ஷன் சார். சார் உங்க பிபிடி வந்து எங்களுக்கு டிரைவ்ல கொஞ்சம் இது பண்ணீங்கன்னா யூஸ்ஃபுல்லா இருக்கும் சார். நாங்க ஏதாவது மிஸ் பண்ணோம்னா ஒர்க் அவுட் பண்ண நல்லா இருக்கும் சொல்றோம் சார்.
Yeah, definitely we'll share it. So whatever we have discussed in last 6 days, videos and PPT also will share it. Yeah. Any other?
Okay, sir. Thank you, sir.
Sir, please conduct few more programs related to MATLAB or some other related programs you can conduct, sir. One more request. Not only MATLAB.
Yeah, definitely.
Sir.
Yes, sir. Please proceed. Yeah, any other? Please give me the feedback.
You're last class now. You're the last class now.
Yeah, if anybody wants to give the feedback, please give me the feedback. Whatever you have learned in the last 6 days. So today is the last day. So please give me the feedback.
Good evening, sir. I am Manivasan. Sir, it's really very.
Yeah, good evening.
Sir, many kind of things I learned from this. I was using this MATLAB for many years. Sir. Many things I understood via this FTP, sir. Thank you, sir. Thank you a lot, sir.
Abba. Data, if you want to share any information, please give your feedback.
If you have the sessions little bit late, like usually 4:30 is our starting time from college. So if it 5 to 6, 5 to 7, something like that, then I also we are able to listen, but we are when we are traveling, we have doing
Yeah, please fill the attendance form. Attendance form is posted from the chat box. Please fill the attendance form. So we will send it the certificate within 10 days. Please check your email. So who is attending for more than 90% of the attendance? Yeah, thank you one and all. Thank you.